You're maybe wondering why Rich Miner and I are on the same program, and the fact is we've both built something that's today used by billions of people. But the other thing is we're both in the connectivity business, and that's the subject of my remarks this evening is connectivity. I recently learned I was going to get the Turing Award for Ethernet, but I thought in collecting my thoughts, I better not just talk about Ethernet, but I'll pop up a level and talk about connectivity, and then to try to make it interesting, I'm going to focus on some of the surprises of connectivity. And if any of you have to leave before I'm done, here's my key message. The most important new fact about the human condition is that we are now all suddenly connected. So what is connectivity? Not to get tangled up in semantics, but connectivity carries stuff from A to B, and the stuff can be mass or energy, or in my case, signals from here and there. There's an old Chinese proverb that says, if you want to be rich, first you build a road. And then there was my ancestor, blind Jack Metcalfe, who built the first 180 miles of roads with his technology, thereby getting England into the Industrial Revolution. So I say we're suddenly connected because my start date is October 29th, 1969, the first day that the internet started switching packets. And in the intervening 54 years, 2/3 of the human race have gotten on the internet. That's about 5 billion people. So I argue that's quickly, suddenly. We are suddenly on the network. And it's this suddenly part of it that catches us by surprise and causes us to run into some of the pathologies of connectivity. So packet switching was the technology of the internet. The internet began packet switching in 1969. And the goal of the ARPANET was resource sharing. ARPA funded the internet in order to, so they wouldn't have to buy so many PDP-10s for each of their principal investigators, but could instead share them using this dial-in network. And the first attempted login was out of UCLA in 1969, and it crashed, the machines, but they later got it working. So now I want you to listen to this surprise, how the ARPANET, the internet, changed its goals in the first year of existence. We began by building a telnet protocol so we could log in at other people's PDP-10s and similar machines. And then we discovered that logging into them was useless if our data wasn't there. So we developed an FTP, a file transfer protocol, to get our data to the other machines so we could run our apps. And then we figured out there were certain kinds of files of interest, files that contained destinations and addresses. And thus email was born. And when I say born, after that, resource sharing was never, not again, the goal of the internet. It was email. So there was the big email transition, which I would date to 1972 or 73. Now we developed layers of progress on the internet, and this was later formalized by the International Standards Organization as the ISO reference model. 7 layers. We organized connectivity into 7 layers. I have to look at the list. Application, presentation, session, transport, network, link, and physical. And I was free, thanks to this architecture of the internet, to work on the plumbing, the physical, and the link without worrying about much what's going on above me at the higher level protocols. And I, therefore, along with everybody else, was surprised when in 1989, Tim Berners-Lee came up with the 3 protocols of the World Wide Web, which really ignited the growth of the internet. The next big transition occurred in 1973 or so. I left MIT, where I was where I put MIT on the internet by building some hardware and software. And I then went to Xerox Research in Palo Alto and did the same thing. That is, connected Xerox to the packet switch that had been installed there by ARPA. ARPA would put a packet switch in each of its research locations, and then it was their job to connect to them. And I did that twice, once at MIT and once at Xerox. And while I was there doing that connection, we all reached a decision. We decided to build what is arguably the first personal computer, the Xerox PARC Alto. And when it came time to divvy up the chores, I lucked out and I got the job of networking these PCs on every desk. Can you imagine putting a computer on every desk? Why would you do such a thing? Anyway, Xerox Research, Palo Alto, decided to do it, and I lucked out by getting the job of building the network to connect those PCs, one on every desk, to one another and to their servers. So as we proceeded building out the internet after the PC transition, early 70s, other things started changing. There was, for example, a platform evolution. When we started building the ARPANET, people were still using punch cards pretty much to get their computing done. And then around the time of the ARPANET, people were using dumb character terminals to do their computing. And then came PCs, as I just said, and then PC LANs, client server, cloud computing, smartphones, Internet of Things, Edge. These are different platforms, and the connectivity of the internet had to accommodate them. Similarly, there was a traffic evolution. The first traffic to go over the internet was uppercase only ASCII characters on an ASR 33 teletype at 10 characters per second. We then later upgraded to the Model 37 teletype, which had upper and lower case, and it had a red ribbon. You could switch to the red ribbon. But the platform evolution continued. We went to web publishing. We added voice, and of course, we added video. In fact, most of the traffic carried, like 82% of the traffic carried on the internet is today video. A traffic platform that was not anticipated. Now, in the environment at Xerox PARC, even though I got the job of building a network to connect the Altos together, there were other alternatives, and competition was fierce. The fiercest competitor was SneakerNet, which keeps coming up in connectivity. SneakerNet is the argument that you don't need a network because you just have to put your file on the diskette, carry the diskette down to the printer and print out your document. And so that was Ethernet's first competition, was convincing people that SneakerNet was not the long-term solution. And there were 6 or 7 other alternatives, some directly competitive. One, Signet, Simoni's infinitely glorious network, I called it anyway. I'm not sure he called it that. And Signet was like a 50 megabit per second version of the ARPA network. And what happened there was we took Charles off the job of building the network, and Butler Lamson convinced him to switch over to building a word processor, which subsequently made Charles the 4th billionaire out of Microsoft. Well, let me describe a funny thing that happened at Ethernet. So we were inventing Ethernet in 1973, and we chose 3 technologies to make that network. One was Gerald vampire taps for puncturing a coaxial cable and connecting to it without cutting it, because we didn't want to bring the network down every time we installed the PC. And then we borrowed Manchester encoding from the University of Manchester. It was an on-off system. In every bit cell, the code would be on half the time and it would be off half the time, either bit bar or bit bar bit. And this had the huge advantage that it contained the clock. There was a guaranteed transition, either to on off or off on in the middle of every bit cell, and that became the clock. So the Ethernet did not have a central synchronized clock, which has always been a problem. And then the third technology was the technology for getting packets sent onto the network so the stations could take turns so their packets wouldn't interfere with each other. And I went to the University of Hawaii and studied there for a month and came back with Aloha Net, randomized retransmissions as a method of interleaving the packets on the network. The other thing I came back with from the Aloha experience was Ethernet would not be a radio network, at least not in 1973. The radios were bigger than the Alto and 1,000 times slower. So Ethernet became not Aloha Network. Its first name, by the way, was Alto Aloha. We changed its name to Ethernet, and we didn't call it coax net because we anticipated that there would be new media in the future. We then improved upon the various methods in, like Aloha Network. We added carrier sense and collision detection and backoff, all of which made it a highly efficient network. Now that was Ethernet then. What about Ethernet now? Well, the Gerald technology for puncturing coaxial cables and the Manchester sequencing encoding method and the Aloha network interleaving access method are all gone. Those are not the fundamental contributions of Ethernet. What happened in the long term is we realized that what Ethernet had done was to bring packets to the desktop. Before Ethernet, the packets were stopped at the mainframe host, typically the PDP-10, and converted into character streams so that the apps would then run and type on these glass teletypes that we had. The second thing that Ethernet contributed was abundant bandwidth. The Park Ethernet ran at 2.94 megabits per second, which was 10,000 times faster than the network that it replaced. And it's 10,000 times, not 10%, not 100 times, not 1,000 times, 10,000 times faster. So after Ethernet, bandwidth became abundant and it became practical to Ethernet joined the movement toward inter-vendor standards. So packets to the desktop, abundant bandwidth, and standards were Ethernet's enduring contributions to the evolution of the internet. 1973 was a big year. That was the year that we worked on Ethernet and started building the Alto. It was also the year that Marty Cooper made the first handheld cell phone call. He worked at Motorola and he called his competitor at AT&T. And so in 73, Ethernet was invented and the cell phone got started. And a third thing happened is that Vint Cerf called for a seminar at Stanford to develop the next generation protocols for the internet. As you may know, Stanford is just around the corner from Xerox Research in Palo Alto. So I got to attend this as a consulting professor. And a funny thing that happened is Vince and I both came to this meeting wanting to add a network number to the protocols. The network control program that already existed didn't have a network number. It just assumed it was one big network. Vint noted that there were fewer than 200 countries in the world, so therefore the network number wouldn't have to be bigger than 8 bits, 256 different countries. I, on the other hand, was looking for a network number, but not because of the countries. I was looking for a network number because we were going to put Ethernets at each of our locations. So we needed huge network numbers to cover all the networks in the world. So we compromised on a 32-bit network number in the protocols, while both looking for network numbers. Now, this connectivity has been sudden, as I argued. The billions of people have joined the internet with this connectivity provided since 1969. And there have been a number of pathologies caused by the suddenness. For example, the first one was hacking. I wrote the first memo documenting 2 high school students cracking the internet, the ARPANET, back in 1973. It was Christmas of 1973. The next pathology was porno. They almost shut the internet down because it carried porno so well. So they passed the Communications Decency Act, and so there's no more porno on the internet. And then came advertising, which the intelligentsia who built the internet were outraged to hear that the internet would be used to carry advertising. They didn't see advertising, as I do, as a method of connectivity, and nor did they anticipate that advertising would very soon become the principal source of funds for the investment in and operation of the internet. After we came to our senses about advertising, we were still stuck with spam, and spam lingered for a while, but we generally don't talk about it anymore. Now we have today's pathologies: censorship, fake news, and so on.